Okay, so I am going to run through this last linear programming problem. And the hardest part of linear programming always is setting up the constraints. Once you got the linear programming problem put together, it requires graphing, finding the feasible region, and corner points. That part is not the most difficult part. So I'm going to go ahead and read this and I'll show you how I go through and organize my information because it's all about organizing the information that's in the problem. Okay, so this says the officers of a high school, senior class, are planning to rent buses and vans for a class trip. Each bus can transport 40 students. Each bus requires 3 chaperones, and each bus costs $1,200 to rent. Okay, so that's a key piece of information. I'm just going to highlight this. This is the information it's saying about the buses. So that's pretty critical. Okay, read on. It says each van can transport 8 students, requires 1 chaperone, and $100 cost. So see, it's given the same information for a bus and a van. And it's telling you how many students will fit in the vehicle, how many chaperones to make sure the kids are, not acting like little jerks and stuff like that, and how much it costs to rent. Okay. And it says since there are 400 students, that's another key piece of information. There's 400 students in the senior class that may be eligible to go on the trip. The officers must plan to accommodate at least 400 students. Okay, so I've just kind of highlighted what's important on the problem. Then another thing it says is there's only 36 parents who have volunteered to be chaperones. That's going to give us constraint. Okay, now the key thing is when you formulate your decision variables in the objective function, that's actually very easy to figure out because the question will tell you what those things are. So let's read the question. It says, how many vehicles of each type? That's what we're trying to find. Just when I see that, that tells me that, well, what are our vehicles? We have a bus and we have a van. So I'm going to say x1 equals the number of let's say that's the number of buses. You can use whatever variables you want. And then let's do X2 would be the number of vans. So the decision variables, read the question. The question will tell you what they are. That's whatever you're trying to find, right? So there's all kinds of possibilities. Maybe it's going to be 10 buses and 20 vans. I don't know. That's what we're going to find out. And then what it says is how many vehicles of each type should the officers rent in order to minimize costs? Okay, so that's critical is this objective function has to do with costs. So we're going to come up with an objective function. Well, cost, the only amount of money that's in this problem is you've got buses cost $1,200 per bus to rent. Then it says a van costs $100 to rent. That'll tell you your cost. Okay, so if you just multiply the number of buses by 1,200, that will give the cost of the buses. Okay, then if you just multiply the number of vans by 100, that'll give you the cost of the vans. Okay, and I'll just pause and think about this if you don't understand this. Let's just say that x1 ends up being 10 and x2 ends up being 2. I'm not saying that's the answer. I have no clue what the answer is. But just think about this. That's going to mean $1,200 for 10 buses is going to cost $12,000. And then it's going to be the 2 vans are going to cost $200 total. So that would be a grand total of $14,000. So you're going to have all these combinations of numbers of buses and number of vans. We're going to use linear programming methods to find which one minimizes the cost. Okay, so hopefully that makes sense to you. That's what we're after. Okay, and once we figure out the constraints, we'll be in business. Okay, so when I look at this problem, now you can always make this in a table or you can just kind of write down information. The key thing I see here is students and chaperones. Okay, so it doesn't really matter how you organize this. I'm going to do like students, whoops, I can't spell. students, and then I've got chaperones. All right, and then we have an optimum number for these. So what we're doing is we have buses and then we have vans. Okay, well, if you just kind of write down your information, the bus, it says it can transport 40 students, but it needs 3 chaperones. The van says it can transport 8 students and it needs 1 chaperone. Okay, and then really the availability of this, the total number of students, we have to have, it says at least 400 students. So we could have more than 100 students. And chaperones, that's 36. Okay, the problem said there were 36 chaperones. So if you go through and look at that stuff, you're going to end up getting an equation. Remember, X1 is the number of buses, X2 is the number of vans. So if you begin to put this together, you can think of it like this. All right, so let's make an equation for students. Okay, so what we would have is every time we rent a bus, it'll hold 40 students. So that mathematical expression, just think about it. If there are 2 buses, that'd be 80 students. 3 buses, 120, and so forth. And remember, we have to come up with enough to take and carry at least 400 students. Then every time we rent a van, that'll take 8 students. So think about what 8x2 means. Okay, if we just use 1 van, then we can bring 8 students. 2 vans, 16 students. 3 vans would be 3 times 8 or 24 and so forth. Now this is at least 400, so it means it's got to be 400 or more. So see, that gives you a constraint. And then we do an equation for the chaperones that goes like this. Okay, every time we rent a bus, which is represented by X1, we need 3 chaperones. Every time we get a van, we only need 1 chaperone. So it's kind of a similar logic on that. Now, the problem said there's only 36 parents signed up. So they're not going to get more than 36. You're just going to say, okay, less than or equal to 36. Because maybe some of them drop out or something when they see what they're getting into with these kids. All right, the other thing is X1 has to be positive. Well, obviously, because it's the number of buses. There is no such thing as negative numbers of buses, and there's no such thing as negative numbers of vans. So what I did is I just did the hardest part of the problem. I organized my information. Sometimes you got to read these problems several times. I don't know immediately how to do these problems. I have to read them carefully, sort and assimilate the information in my mind, sometimes even play around with it a little bit. But now I've got the linear programming problem put together. I've got my objective function. I got my constraints. So now it's a little bit more straightforward to finish. So what we're going to do is we're going to graph these constraints. Okay, so I'm going to just do this kind of over the side. Let's start with this equation. And really the thing to do is just work with the intercepts. Okay, so if you want to get the x1 intercept, you let x2 be 0. So you would really just end up solving this equation to get the x1 intercept. To get the x2 intercept, you would let x1 go to 0, so you would end up solving the equation 8x2 equals 400. Okay, simple to do that. Divide by 40. That's going to give the x1 intercept is 10. And over here, you can divide by 8. And that's going to give the x2 intercept is going to be, let's see what that is then. I think that's 50, right? Yeah, that's 50. Okay. Okay, so we got that. So that means we're ready now to graph that. Now we need to figure out a sensible scale. Usually what I like to do is go ahead and get my intercepts before I graph. So anyway, I've got that. Now I'm going to do the second inequality, which is 3x1 plus x2 is less than or equal to 36. So if I do an x1 intercept, I block out the x2. x2 goes to 0, so you have the equation 3x1 equals 36. Divide by 3, you're going to get x1 equals 12. Okay, to do your x2 intercept, you let x1 go to 0, so you just have x2 equals 36. All right, so these are our intercepts, and then that'll tell us kind of how we need to get this graph put together then, see. Okay, so it looks like the x1 axis, which is going to be this, we need to go up to 12. So I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 1, 2, 3, 4, 5, 15, like that. That's good enough. The x2 axis needs to go up to 50. Let's try every 3. Every 3 is 10. So that's 10, 20, 30, 40, and then 50. Okay, and let's graph these two things. So let's graph this one in red. And to do that, we just need to get these intercepts. So we have x1 is 10, and then we have x2 is 50. So that'll be a line. Try to use a ruler and make sure everything's real accurate on these problems when you do these too. So I'm going to try to use a straight line and get that put together real nicely. Okay. Then I'll pick another color and then I'll do this. So we have the second graph, we have x2 intercepts 12, or x1 intercepts 12, x2 is 36, be right around there. So I'm going to go ahead again and I'm going to use a straight line to get this, pretty accurate. Okay, there we go. All right. Now we need to figure out our feasible region. So remember what happens in this problem is, this is the key thing. You're above the red line because that's greater than. So just think in your mind that you are above the red, and then you are below the line that I had in green. So just think about that being below like that. So think about where you are. You're above the red, which means you're out here. You're below the green, so where would you be? Yeah, you would be right in this little region right here. Okay, that's going to be the feasible region. It's like a triangle. So that's going to allow us to do our corner points then. So if you're above the red and below the green, you have to be in that region. So what you have is you have a triangular region, which is going to have 3 corner points. Okay, well, these are easy. Okay, that's 10, 0. You can tell by looking at the graph. That one's 12, 0. And then this one we have to do a matrix on. So we have to find the intersection of these two. So what we're going to do is we're going to do an augmented matrix, 48, 400. This is, I think, the fastest way to learn how to do this, is just to do the augmented matrix. Okay, so I'm going to put that in my calculator. And let me get all this stuff cleared off of here. So I'm going to go second matrix. Let's see, I need a 2 by 3 matrix. So let's see if I've already got a 2 by 3. I got a 2 by 3 here, so I'm just going to type over this one. 2 rows, 3 columns. And let's put in the numbers. So the first equation, we had 40x1 plus 8x2. And then we had that equal to 400. Okay, that comes from the first inequality. And then the second one was 3x1 plus 1x2. And then 36. Okay, like that. So you want to get that put in. So there's our matrix. Got the matrix put in. Now we want to go quit to get to a clear screen, back to matrix, and then do the math command to get down to reduced row echelon form. Okay, all right, so we're going to do that. And then go back to matrix. We put this, I think, in matrix C. So you can just highlight 3 and press enter. So what we're going to do is the reduced row echelon form of that matrix. And once we do the reduced row echelon form, we get this, okay? And that's going to give you where our other corner point. We're done with the problem yet. That just gives us another corner point. So that corner point, what that means is when we do this matrix and we end up getting 1, 0, 7, 0, 1, 15, it just means that that point of intersection is the point 7, 15. So that gives us our third and final corner point. All right. Okay, so now what we do to finish up the problem, the last step is we need to take the objective function and then we just need to evaluate them. Okay. All right. So again, that matrix, if you didn't get that written down, it just gave 1, 0, 7, 0, 1, 15. Okay, now your objective function is C is 1200 x1 plus 100 x2. Okay, so we're just going to take each corner point and plug it in. Let's start with 10, 0. Okay, so what we would do is C would be 1200 times 10. Zoom on that just a little bit here so I can see what I'm doing. Plus 100 times 0. So that would give a total of $12,000. And what that means is you're renting 10 buses and no vans. Okay, the next corner point is 12, 0. You got to test all of them. So this would be 1200 times 12 plus 100 times 0. Okay, you can do that on the calculator if you need to. 12 times 12 is 144. So that would be $14,400. And then the last corner point is 715. And what the 715 means is that means this would be you rent 7 buses and 15 vans. So you do the same thing. This time we're going to do 1200 times the 7 buses plus 100 times the 15 buses and just do that. Okay, you can do this on a calculator, so just do it in one step if you want to. 1200 times 7 plus 100 times 15 is going to give $9,900. Okay, so that's the minimum. So that would give you the optimal solution on this by linear programming methods then. That gives the minimum. So what we do now is we just write the answer. 7 buses and 15 vans cost $9,900. And that would be the final answer of the problem. Okay, it's hard to tell by looking what the optimum solution is, but that's the idea. Once you get the linear programming problem built, then you got to just do some graphing. You got to figure out corner points, which often you need to do something with a matrix and evaluate your objective function. So that is the optimum solution. Okay, so that will wrap that video up then.